Okay, so it is with great pleasure I introduce a good friend of mine. FX and I have known each other since, was it DEFCON 9, where we ran into each other out in the pool, and I was trying to keep him supported while he was telling me about his talk, and I discovered he's a really smart guy. So you're going to learn a lot from him, but we have to start with a couple of shots of Jägermeister, so... Good
awesome,
talk.
man. Thank you. Oh yeah, bring more Jaeger. Today we're talking about safer sex online, how to get not owned by watching porn. Because the problem being the porn comes in flash files. So, just in the beginning, it's a defense talk. So I'm not semantic, so I'm not telling you this is going to protect you 100%, because defense and security is actually just about making shit happen less often. You can't really prevent it from happening all the time. So this is what I want to talk about here. We're going to quickly go over the motivation of this work. So the five of you that probably sit there go like, Cisco and then Flash, what the fuck? This explains why. And then the Flash attack surface and who actually has issues with Flash security. And I'm getting to the tool demo pretty quickly, so you can either switch talks or then sit through the rest and see how it works. So the idea, this whole thing was actually initiated by a project from the German Federal Office for Information Security. In contrast to your NSA, our office actually also cares about the citizens and the citizen security. And that's actually their official mission partially. So they care about things like Flash and client-side security. And so we looked at a couple of rich internet application platforms, and Flash essentially turned out to suck a lot more than all the others in terms of security. And we tried to figure out how to fix that and unfuck Flash without firing everyone at Adobe. Because that just simply wasn't in our reach. Not that I would have not considered it. And then we also discovered that the traditional detection methods actually don't work too well. And I'm coming to this in the talk. And we see a shitload of new Flash exploits all the time. And we didn't want to build yet another antivirus engine, so we wanted to build something that is signature-free, that is, if the code is actually working, doesn't require any attention anymore, and not constant updating and stuff. So that is the higher theoretical goal behind this work. What type of attack surface are we looking for when we load a Flash file into a Flash player? Well, the things that usually break in software when you try to exploit it are parsers, like the piece of code that actually takes apart the protocol or file format. And now the Flash file format is actually a container format that contains vector graphics, pixel graphics, fonts, sound data, video data of all types, and virtual machine code. What can possibly go wrong? Pretty much everything. So let's say 80% of the software is parsing, and it's all written in C by people from Adobe, and hence we have a problem. So the first type of person that has problems is end users, like you get owned by surfing porn. What commonly happens is you have a malicious Flash file somewhere in a web page, or malicious Flash is loaded up while you're watching the porn in the background. And then your Flash player plugin in a browser gets popped, and, well, you get owned. And this is, in almost all cases, by modifying the Flash file format in a way that when it is parsed, the parser breaks, like integer overflows and buffer overflows, basically. You also have functionality-based attacks, like DNS rebinding, CSRF-style attacks, where you essentially use Flash to speak UPnP to your home router and open a port so it gets forwarded, or it is used in exploit toolkits. The problem is 97% of all browsers have Flash. And a quote I I heard someone saying was telling people not to use Flash is like telling people to not smoke. That doesn't work. So, what the end user actually wants is something that does Adobe's job, which is validating that the file he is about to load in the Flash player is actually valid and well formatted, because if it's valid and well formatted, then it's probably not going to make the Flash player fall over. And if you can guarantee that it's well formatted, then you probably have a file that you can watch without getting popped. The thing here is that you actually really want to have that in your web browser on demand. And for end users, performance of such a method for protection is actually critical. As AV vendors know all the time, because people hate to wait for their porn. So if it's, if it loads slowly, then, it's not cool. Unless you grew up in the mailbox times, then, you were used to seeing people in pieces. The other group of people that actually really suffer from Flash attacks are website owners and ad networks. Interestingly enough here, it's not file format based attacks that they're concerned with. It's actually functionality based attacks. So, there is program code in Flash files. And of course you can program your banner to go to a non-malicious URL. Hello. To go to a non-malicious URL. And then it gets uploaded into the advertisement network, and they click on it, they test it, they see it's fine. They put it out into the content distribution network, and then your banner changes behavior and forwards users' browsers to malicious sites. That happened to a couple of news media sites, including the New York Times, so it's an actual problem for them. Their requirements on Flash security are somewhat different. Sure, well-formatted files is also of interest to them because it helps the people testing the Flash files not getting owned. But desired is also the ability to say, well, contractually, we give you banner space to forward to users that click on your banner to this particular URL. If you're diverting it, if you're forwarding them to a different URL, you're violating the contract. The problem is today they can't verify that. They have to trust the code because they get pre-compiled Flash files. And it would be nice for them to say, well, we enforce that the code actually cannot do anything else. That, of course, is more computational expensive, meaning you need more CPU power. But that's not a big problem for them because they will run at server side. They will actually run a verification process the moment the Flash file gets uploaded. So we have Flash provides its own security. Not. There is some configuration, right? There's very limited configuration options. Like you can turn on and off the camera. For whatever that helps you if you got owned. And there is the possibility to disable a lot more things, like disable file uploading or downloading. The problem is that sits in some configuration file that nobody actually uses. What the hell's going on next door? Do they have naked chicks or something? And another thing that Flash simply doesn't have in terms of security is proof of origin. So there is absolutely no way that you can tell where the Flash came from. There is no signature mechanism whatsoever. And then there is AVs. So here's the thing about AVs and Flash. Flash files can be, and most commonly are, zip compressed inside. Like the whole thing is zip compressed. They can be uncompressed, functional equivalent, it's just that it's compressed. So when you take the most common malware, GNIDA it is called, no idea who came up with that name. If you upload that to VirusTool, you get a coverage of about 70%. Now this is the compressed file. If you simply uncompress the file, it's still the same file, it's just unzipped. And you upload it again, only 8 out of 40 AVs even detect the most common Flash malware that we've ever seen. So AVs are an epic fail when it comes to Flash. Scratch the part when it comes to Flash. So we had an alternative approach on this. So what we provide is a straight command line program similar to a command line AV. And what it does is you give it a Flash input file that is potentially malicious, and you will receive an output file that is hopefully not. As simple as that. The idea here is that we actually run complete format verification on the file, and then produce a new file for you. And how do you use that? Well, we figured that we first, with the release, are going to target people that are security conscious anyway. So I thought if you're surfing with the IE6, then you probably don't care about Flash security because you have other problems. But if you're surfing with Firefox and NoScript, then you're probably aware of a few of the things that happen on the internet. And so you're probably more helpful as a target customer group. Giorgio Maoni, the author of NoScript, was nice enough to build a external filter interface that I proposed to him. So you can hook up other programs. You can write your own programs now that will do filtering of specific MIME types, and then you can hook them into NoScript with no coding whatsoever. But he built it actually for us so we can integrate our Blitzableiter into this NoScript thing. It required a lot of work on his side, and it's currently up and running. If you're up on the latest version of NoScript, you already have that option and you can configure it. And at this point, we would like to thank Giorgio very much, because it's not like we had to beg him or something. It was sending him one email proposing this, and he's like, it's cool, and then he started writing code. I think I forgot to mention one thing. The name of the tool, Blitzableiter, is a German word, intentionally, just to make it harder for you guys. It is the term that we use for lightning rod, because it turns dangerous lightning into, pretty flashes that don't kill anyone. So that's for the name of it. So here's how the NoScript integration looks like. It's really just the external filters tab, and then you choose the exe file. And he also integrated it into the context menu. So for example, if the tool will not allow you to see a certain piece of porn and you really want to see it, it's one click away to say, for this site, don't run a filter, I want to get owned, the chick is just too hot. So. If you want to integrate Blitzableiter into web pages, that's also a trivial thing since it's command line. You're just running it on the web server when the upload happened and check the return value, the operating system exit value of the program. Works the same way every command line AV ever worked. Depending on the feedback we get, we're going to set up a XML RPC or a SOAP or whatever service, so you can use Ajax or whatever to send Flash files first to us and then get the Flash files from us into your web platform. If you want to have such a service being implemented, then please contact us, drop me an email, something like that. It would be easily doable, but I'm sick of doing stuff that nobody wants to use. And it's open source. Because I don't believe in black or yellow boxes that promise to make me secure and someone else rich, because they usually only fulfill the second requirement, and that is not good. So I believe that we should actually start applying Kerckhoffs's principle from the cryptography world to the defense world, saying if you use a defense mechanism, you have to be able to verify that it actually does what you're expecting it to do. And for this, the source code is very helpful. We would also love to see integration into other pieces of software, so you're welcome to sign up and get the source ball. That's the URL, but it's going to be on the last slide anyway. And now I'm going to show you the thing in order for you to judge whether to listen to the second part of the talk or not. Now, how do we do that?